Hello ladies and gentlemen, welcome back. We are now going to be our halfway mark for Geometry Goal 1. We're going to be talking about angles, getting you used to all of the different conventions and names, and specifically how to use a protractor. Then we're going to get into some fun stuff, i.e. some of the DSA topics where we talk about angle addition. First things first, let's actually get used to angles themselves. This is, and I talked about it in a prior video, this is one of those things where you have a manipulative in the Alex software itself. And because I'm doing screen grabs, I don't really have the chance to show off what you're doing. What you're going to do is you're going to pull out this thing, which is called a protractor. Protractor, one of a geometer's best friends. And what you're going to be doing is you want to take note where the edges of your angles are, and you want them to line up. So the center, you can kind of barely see this red line right here. You want that to be on this, which is the vertex of your angle. And then you want the zero side of your protractor to line up with, obviously, your zero. Then from there, you trace your way around, and here the measure of this angle is 170. And a side note on notation, you see this right here? Again, symbols are going to be a thing in geometry. That's the measure of the angle. So if you see an M in front in the computer, let's see if I can make it look good. It will look like this, measure of the angle. But again, Ms. Dubois' handwriting is terrible, so mine is going to look like this, measure of an angle. Again, next thing they're going to do is they're going to ask you to make it with a protractor. So if you have to make a 160-degree angle using a protractor, you're going to have two tools. You're going to have your protractor, but you're also going to have a straight edge. Start here, and I couldn't get a screen grab of it. You're going to start with your straight edge, make a point, and then you're just going to make your straight line. Then, exactly like you were doing up over here, you're going to take your protractor, line it up to the center, line it up to the zero, and then you're going to take your pencil and make a dot at the 160 mark. Once you have your dot at the 160 mark, you can take your straight edge again and line it up from your vertex to the dot you just made in order to make your angle. I wish I had the actual interactive software so I could show you how it was done. This was the best I can do. I hope it works sufficiently. Now, types of angles. Let's see if we remember which is which. A cute little angle is a small little angle, which means it's less than 90 degrees. A right angle is just like Goldilocks, just right, which means it is exactly 90 degrees. You can tell a right angle, by the way, because you're going to see a little box in it for most of the diagrams in geometry. They don't give it to you for this one because they want you to get used to it first, but just FYI. An obtuse angle, well, if you're being obtuse, that means you're being a little wide, so that means you're greater than 90. And I think those are all the ones you have right now. There is technically, for extra credit, something called a straight angle, and that one is going to be 180 degrees. So there's a straight angle right there, just for yucks. So if we're looking here, angle A, that's 90 degrees. So since I know that, that's going to be a right angle. Angle B is 75. 75 is a cute little angle. Oops, what did I just do? Angle A is a right angle, Ms. Dubois. Angle B is an acute angle. So obviously pay attention to where you're labeling, unlike Ms. Dubois. Angle C is feeling a little obtuse. And angle D is just right. And over here, same thing again. Angle A is 70, which means it's a cute little angle. Angle B is 140, so it's feeling a little obtuse. 60 is a cute little angle. And then angle D is just right. Getting used to that. Next up, we want to get used to how angles are named. And this one is one where you kind of want to take a little bit of time to sink into. It's okay to get one right and one wrong. Because if I'm going to look at before I even look at this, I'm going to look at this angle right here. That has 3 names, and you have to get used to that. So you have the best kind is when you just can say angle 1 because there's a little number inside. But sometimes the universe is not that nice to you. So the other way you can name it is you can sort of trace your way around the angle. So if I traced it this way, that's angle A, B, C. Well, not everyone traces counterclockwise like Ms. Dubois. So what if we actually traced counterclockwise? That would be angle CBA. And that's how you're going to be naming your angles. Take note that your vertex, if we remember from before, vertex is the actual point of your angle, the pointy part. So there's my pointy part. Your vertex is always, 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 always going to be your middle number. So when it says look for, write two other names for angle CBD, you have to go up and trace it, CBD. So you can label it as angle 2, or you can label it as angle DBC, because what I'm doing is I'm taking the letters and I'm reversing them. What is the vertex of angle DBA? I don't even need to look at it. There's my middle letter, so it's going to be B. Name the sides, there we go, the sides of angle 1. Okay, sides, we remember from our definitions, is going to be a ray, so we're using our ray symbols here. And remember, for rays, this has to be your endpoint. So both of these are going to start with the letter B. So for angle 1, it will be BA, and that was a terribly written A. Let's try that again. It will be angle BA or BC. So that's the walkthrough. Let's go through a couple more examples, make sure we're good. Vertex of angle 1, what's the pointy part? It's going to be F. Name the side, so this is our ray stuff. GFE, so we're going to have GFE, so our first one is FG, FG, and then FE. And what are the other names for angle 2? We have angle 2, EFH, EFH, and then if I trace around the other way, it will be HFE. Sides of 1, so that's the ray. So we have QT, oh, what a cutie. And then what's the other option? QR. Well, there's nothing quite as good for that. There's no pun there. Vertex of SQT is going to be Q because that's our middle letter. The two other names for RQS, so we can do angle 2, or we can reverse the letters and say angle SQR. All right, almost done. Last little bit. This one is kind of an awkward topic. I couldn't really fit it anywhere, and this was the best place I could put it. Let's see here. What are we told? We have baseball. We have, just as a quick reminder, how many degrees are in a circle. My skateboarders should know this. There are 360 degrees. So what are we looking for? Table below summarizes. Find the central angle of x degrees. So it's going to be x degrees, and because it's degrees, how many degrees are there? 360. And then what do we have? It's baseball. So what is baseball? 8% out of 100. Well, gosh and golly gee, that's a proportion. We know how to solve those. Cross multiply, so it's 100x equals 8 times 36. 24, 288. 0, divide by 100, divide by 100. So x is going to be 28.8 degrees. And that sounds about right. How about this one? What do we have? We have 450 members. Okay, it's x degrees, so it's going to be x over 360 again. All right, and then it's out of the 450, and it's the humanities, so humanities is 135. So 450x, because we're cross-multiplying, equals 135 times 360. I am good, but I am not that good. What is 135 times 360? 48,600. So that's going to be 48,600. And then I need to divide by 450, divide by 450. So divide by 450 equals 108. So our x here is going to be 108 degrees. And that is everything for Geometry Goal 1 Group 5. Now we know our basics for our angles. The next thing we're going to do is we're going to dive and jump and just fall in love with everything to do with angle addition. As always, stay happy, stay healthy, stay safe. I'll see you in the next one.